In the humid darkness of the Florida coast, a Titan stood patient. It was a monument not of stone, but of ambition wrought from advanced alloys and woven with miles of intricate wiring. This was New Glenn, a name that echoed the pioneering spirit of the first American to circle our world, now embodied in a colossus aimed at a world beyond our own. For weeks it had been a silent sentinel on the pad at Launch Complex 36, a silent promise against the sprawling canvas of the night sky. The world had been watching, waiting for the thunder, for the fire, for the moment this terrestrial giant would defy its earthly bonds. But the sky had remained quiet, the countdowns frozen, the hopes deferred. The adversary was not a rival corporation, nor a failure of engineering. The source of the agonizing delay was the very heart of our solar system. Our sun, the giver of life, had become an unpredictable antagonist. From 93 million miles away, the star that nurtures our planet had been lashing out with unseen fury, a temper tantrum on a cosmic scale. It had unleashed colossal storms of charged particles, great tsunamis of plasma known as coronal mass ejections hurtling through the void. These ethereal waves, invisible to the naked eye, are devastating to the delicate electronics that form the nervous system of any modern spacecraft. To launch into such a tempest would be to send a ship of glass into a hailstorm. The precious cargo nestled in New Glenn's enormous fairing, a pair of probes destined for Mars, would be rendered inert, their billion-dollar minds scrambled before they ever left Earth's protective magnetic shield. And so humanity waited. The engineers, the scientists, the dreamers. They watched the sun scrutinizing data from a fleet of solar observatories, tracking the celestial weather with the same anxiety a mariner tracks a hurricane. Each passing day of inaction was a reminder of our profound fragility, a testament to the fact that for all our technological prowess, we are still subject to the primordial forces that govern the cosmos. The delay was a lesson in humility, a pause forced upon us by a star's caprice. This grand vessel, this behemoth of methalox and metal, is the culmination of over 2 decades of methodical, often secretive development by Blue Origin. Its name, New Glenn, is a deliberate and deeply symbolic choice. John Glenn, in his tiny Friendship 7 capsule, was a trailblazer, a man who strapped himself to the tip of a converted missile and entrusted his life to the calculations of a fledgling space program. He represented a frontier spirit, the courage to venture into an unknown that was not just vast but hostile. This new rocket, this ascendant giant, was conceived to embody that same ethos for a new century of exploration. It is a machine built not for fleeting orbital sprints, but for the long haul. Its purpose is to open up a permanent, sustainable highway to space, and its first operational mission was a declaration of that intent, Mars. To truly comprehend the leap in capability this rocket represents, we must understand its fundamental design philosophy, reusability. For over 60 years, the paradigm of space travel was one of extravagant waste. Imagine if, after every transatlantic voyage, an ocean liner was scuttled, its immense hull, powerful engines and sophisticated navigation systems all discarded at the bottom of the sea. The cost would be astronomical, the very idea of routine travel rendered impossible. Yet this is precisely how we have treated our rockets, the most complex machines ever built. We would pour hundreds of millions of dollars into a launch vehicle, only to watch its most expensive components burn up in the atmosphere or crash into the ocean just minutes after a spectacular fiery birth. New Glenn was engineered from its very inception to shatter this paradigm. Its first stage, the powerful booster that provides the initial Herculean thrust, is not disposable. After lifting the upper stage and its payload towards orbit, it is designed to perform an extraordinary maneuver. It detaches, flips itself around, and executes a series of precise engine burns to slow its descent. Guided by grid fins that bite into the thin upper atmosphere, it steers itself not toward a watery grave but toward a moving platform far out in the Atlantic. This landing is a ballet of fire and computation, a 17-story building descending from the edge of space to land with pinpoint accuracy on a ship at sea. The success of this recovery is not merely a cost-saving measure, it is a philosophical shift that transforms the economics of space exploration. It changes a rocket from a single-use firework into a reliable, reusable transport capable of flying again and again, making the journey to orbit routine and the journey to other worlds finally truly plausible for a wider array of missions. The 7 BE-4 engines at its base, each a masterpiece of engineering, are the heart of this capability. Burning liquefied natural gas and liquid oxygen, they represent a new generation of power plants, more efficient and cleaner than the kerosene-based engines of the past. They leave behind less soot, making the refurbishment process for the next flight simpler and faster. Everything about this machine whispers of a future where space is not just a destination for government-backed missions, but a domain for science, commerce, and eventually a persistent human presence. The long weeks of solar-induced stasis had given the world ample time to contemplate the sheer audacity of the machine and its mission. The twin probes named Ares Sentinel and Deimos Pathfinder were nestled within the cavernous payload, faring a clamshell structure so large it could comfortably swallow a school bus. They represented two distinct but complementary approaches to unlocking the secrets of Mars. Ares Sentinel was a sophisticated orbiter, an interplanetary detective designed to investigate one of the greatest mysteries of the solar system, how a once warm, wet world with rivers, lakes, and perhaps even oceans transformed into the cold, desiccated, and seemingly lifeless planet we see today. Its primary objective was to create the most detailed map ever of Mars's tenuous magnetic field and to directly sample the upper wisps of its atmosphere as they are stripped away by the relentless solar wind. To understand this mission is to understand planetary evolution. Earth is protected by a powerful global magnetic field, an invisible shield generated by the churning molten iron in its core. This magnetosphere deflects the same charged solar particles that had delayed New Glenn's launch. Mars, for reasons we do not fully comprehend, lost its global magnetic field billions of years ago. Without this protection, the solar wind began a process of cosmic erosion, slowly but surely sandblasting the Martian atmosphere into the void particle by particle over eons. The water on its surface, no longer sustained by sufficient atmospheric pressure, either boiled away into space or froze solid, retreating into subsurface glaciers and polar caps. Ares Sentinel, with its suite of magnetometers and plasma analyzers, was built to fly through the remnants of this process, to taste the escaping ions, to measure the electric currents, and to witness the slow death of a world in real time. The data it would gather was not just about Mars's past, it was a cautionary tale about the delicate balance that makes a planet habitable, a narrative written in the language of physics that could inform our understanding of planetary climates, including our own. Its companion, the Deimos Pathfinder, was arguably the more audacious of the two. It was not a lander for Mars itself, but for its strange lumpy moon Deimos. Both of Mars's moons, Phobos and Deimos, are cosmic oddities. They are small, irregularly shaped, and look more like captured asteroids than traditional moons. A persistent theory suggests they are indeed interlopers from the asteroid belt gravitationally ensnared by Mars long ago. But another, more tantalizing hypothesis proposes they are remnants of a colossal impact on Mars itself, chunks of the Martian crust thrown into orbit by an ancient cataclysm. If this were true, then Deimos would be a time capsule, a piece of primordial Mars preserved in the vacuum of space, far from the weathering and geological activity that has altered the planet's surface. Deimos Pathfinder was designed to test this theory. Its mission was a high-wire act of celestial mechanics. Landing on a body with almost no gravity is less like a traditional landing and more like a gentle, controlled docking. The probe would approach the tiny moon with excruciating slowness, firing its thrusters in tiny puffs to match its orbit perfectly. Upon contact, it wouldn't land with a thud, but would instead fire a series of harpoons into the moonlet's surface to anchor itself, preventing it from simply bouncing off back into space. Once secured, it would deploy a small drill designed to penetrate the regolith and extract a core sample. An onboard laboratory, a miracle of miniaturization, would analyze this sample's isotopic composition. If the ratios of elements matched those of Martian meteorites found on Earth, it would be a smoking gun proving Deimos was born from Mars. Furthermore, it would search for water ice, which, if found in abundance, could make these tiny moons vital refueling stations for future human expeditions, outposts where astronauts could harvest water for drinking, for oxygen, and manufacturing rocket fuel. This single small probe carried the potential to rewrite the history of the Martian system and pave the way for its future exploration by humanity. The agonizing wait on Earth was a direct consequence of the immense sensitivity of these instruments. The electronics that controlled the probe's guidance systems, their communication arrays, and their scientific sensors were exquisitely vulnerable. A single high-energy proton from a solar flare striking a microchip in just the wrong place could flip a digital bit from a 1 to a 0. This seemingly trivial event, known as a single event upset, could corrupt a command, disable a system, or render an entire instrument useless. A more intense barrage of particles could cause permanent damage, effectively lobotomizing the spacecraft. Launching during a solar storm was a multi-million-dollar gamble with impossibly high stakes. The mission planners in Blue Origin's control center knew this. The pressure was immense. The world's media was focused on the grounded rocket, on the repeated postponements. Skeptics whispered about technical troubles, masking failure with excuses about the sun. But inside the control room, the mood was one of steadfast patience, of discipline. They were not just rocket engineers. They were custodians of a scientific dream, and they would not risk that dream on a reckless roll of the cosmic dice. They were sailors of a new ocean, and they knew to respect its weather. Then, finally, the celestial forecast began to clear. The sun's active regions, the sprawling sunspots that acted as cannons for plasma ejections, had slowly rotated out of view as the sun spun on its axis. The stream of high-energy particles bombarding the Earth's magnetosphere began to subside. A window of cosmic calm was opening. It would be narrow, perhaps only a few days, but it was enough. The word went out. The countdown would resume. A palpable current of energy surged through Cape Canaveral. The quiet anticipation that had settled over the space coast for weeks was replaced by a focused electric hum. The final preparations began. Thousands of tons of cryogenic propellants, liquid natural gas and liquid oxygen chilled to hundreds of degrees below zero, started to flow into the colossal tanks of the New Glenn. The rocket, which had stood inert for so long, began to come alive. Plumes of vapor, the frigid fuel boiling off as it touched the warmer tank walls, ghosted from its sleek white fuselage, making the giant appear to breathe. It was a spectacle of immense power being carefully contained, a sleeping beast being gently roused for an extraordinary exertion. In the final hours, the sky over Florida was a perfect star-dusted black. The air was still as if the planet itself was holding its breath. The voices on the mission control loop were calm, methodical, a litany of checks and verifications that belied the monumental event about to unfold. Guidance is go, propulsion is go, range is green. Each call was a single thread being woven into a tapestry of confidence, a final confirmation that every one of the millions of components in this towering stack was ready to perform its function flawlessly. The final 10 seconds of a countdown are a unique passage of time. Each second stretches, filled with the weight of decades of research, the investment of billions of dollars, and the dreams of generations. 10. The sound suppression system begins to flood the launch pad with hundreds of thousands of gallons of water, not to extinguish a fire, but to absorb the cataclysmic acoustic energy that could otherwise shatter the rocket. 9. The vehicle switches to internal power, severing its final umbilical connection to the Earth, becoming an autonomous entity. 8. The spark igniters at the base of the 7 BE-4 engines prepare to awaken the beast. 7. 6. A final moment of profound silence. 5. 4. The ignition sequence begins. A flicker of green flame, the characteristic color of burning natural gas, appears beneath the rocket. 3. 2. The flicker erupts into a controlled inferno as all 7 engines ramp up to full thrust, generating over 3.5 million pounds of force. 1. The launch clamps release. 0. Liftoff. There is no immediate sense of speed. For a heart-stopping moment, the 400-foot-tall Colossus seems to hang in the air, balancing on a pillar of incandescent light. It rises with an almost agonizing slowness, a deliberate, majestic assertion of power over gravity. The ground for miles around begins to tremble, a deep primal roar that is felt more in the chest than heard with the ears. It is not a sound, it is a physical presence, the sound of tearing the very fabric of the atmosphere. Then the acceleration builds. The behemoth climbs, gaining velocity with every passing second, a brilliant man-made star ascending into the heavens. It punches through a thin layer of clouds, momentarily illuminating them from within like a celestial lantern, before re-emerging a searing point of light against the infinite black. Inside the mission control room, the stoic professionalism gives way to a wave of relief and elation. The most dangerous phase of the mission, the violent birth of the launch, is over. But the journey has just begun. Higher and faster it climbed, an arrow of fire aimed at the heavens. Onboard computers, constantly adjusting the gimbal of the engines, steered the rocket on a precise, pre-calculated trajectory. The vehicle approached the moment of maximum aerodynamic pressure, max Q, the point where the combination of its velocity and the surrounding air density exerted the most intense physical stress on its structure. It passed through this invisible barrier without incident, a testament to its robust design. Minutes into the flight at the edge of the discernible atmosphere, the first stage's work was done. The 7 BE-4 engines throttled down and shut off, plunging the vehicle into a sudden, eerie silence. Explosive bolts fired, and pneumatic pushers separated the massive booster from the second stage. For those on board, were there any passengers, the experience would shift from a bone-crushing G-force to the gentle, untethered freedom of zero gravity in an instant. As the second stage ignited its own vacuum-optimized engine to continue the push toward orbit, the first stage began its second, equally important mission. It was now a spacecraft in its own right, traveling at hypersonic speeds, but its destination was not orbit. It was a tiny patch of ocean hundreds of miles away. It deployed a set of 4 large grid fins near its top, articulated fins that looked like giant waffle irons which would be used to steer it through the atmosphere. It performed a boost-back burn, firing its engines to reverse its course, and then a re-entry burn to protect itself from the searing heat of its plunge back to Earth. This was the ballet, the carefully choreographed descent from the heavens. Back on the ascending second stage, another milestone was reached. Now, clear of the dense atmosphere, the protective payload fairing was no longer needed. With another sequence of small pyrotechnic charges, the two halves of the clamshell split apart and fell away, revealing the Ares Sentinel and Deimos Pathfinder to the naked void for the first time. Bathed in the unfiltered light of the distant sun, they were pristine, their solar panels folded, their antennas stowed, awaiting the moment they would begin their own long journey. The second stage engine burned for several more minutes, placing the probes into a stable parking orbit around the Earth. Here they would circle the planet once a brief pause that allowed for final system checkouts, and for the vehicle to be positioned perfectly for its ultimate departure. Far below the first stage booster, having survived its fiery re-entry, was now approaching the landing ship. Its central engines reignited for the final landing burn, a plume of fire acting as a colossal retro rocket, slowing the towering cylinder from supersonic speeds to a gentle hover just above the deck. 4 landing legs deployed, and with a final delicate puff from its engine, the booster settled onto the deck with astonishing precision. A pillar of smoke and vapor billowed across the ship, and then silence. The stage was safe. The reusable dream was a reality. The crowd at Mission Control, which had been watching 2 simultaneous critical events unfold, erupted in applause. But the main event was yet to come. As the second stage and its precious cargo completed their lap around Earth, they reached the precise point in space and time for the trans-Martian injection. On command from the ground, the engine reignited one last time. This was the final decisive push. This was the burn that would change their orbit from one around the Earth to one around the Sun, an elliptical path that would, after a 7-month voyage across more than 300 million miles of interplanetary space, intercept the orbit of Mars. The engine fired for several minutes, a sustained, powerful acceleration, adding thousands of miles per hour to its velocity, enough to finally break free from Earth's gravitational embrace. When the engine cut off for the final time, the vehicle was no longer in orbit around our world. It was on an escape trajectory. It was truly on its way. A short time later, a spring-loaded mechanism gently pushed the Ares Sentinel away from the upper stage. It drifted slowly, serenely into the blackness, a silver and gold jewel tumbling against a backdrop of distant stars. Minutes later, the Deimos Pathfinder followed suit, beginning its own independent journey. Soon their onboard computers would awaken. They would deploy their solar arrays to draw power from the sun they had so patiently waited for, and they would begin communicating with Earth, confirming their health after the violent rigors of their departure. Their successful launch was more than just a corporate milestone for Blue Origin. It was a landmark moment for the entire space industry. The arrival of a new heavy-lift launch vehicle, especially a reusable one, fundamentally alters the landscape of what is possible. It creates redundancy, it fosters competition, and it dramatically increases humanity's total capacity to lift mass off our planet. The success of New Glenn meant a new and powerful gateway to the solar system was now open. The data that Ares Sentinel and Deimos Pathfinder will send back will occupy scientists for decades to come. We will learn more about the slow, tragic transformation of Mars, gaining invaluable perspective on the forces that shape planetary habitability. We may discover if its moons are captured wanderers or children of the planet itself, and whether they hold the resources needed for our own future journeys there. These probes are our robotic emissaries, our eyes and hands extending our senses across the vast, cold emptiness of space. They are the tangible products of our insatiable curiosity, the same curiosity that compelled our distant ancestors to look up at the night sky and wonder what those points of light could be. As the probes dwindle to faint signals on their long trajectory, the New Glenn booster is being brought back to port to be refurbished, refueled, and readied for another flight. Its next mission might be to deploy a constellation of satellites or to launch a new space telescope to peer into the dawn of time, or perhaps to carry the components of a lunar lander that will one day return humans to the moon. This launch, born of patience and persistence, was a powerful statement. It was a demonstration that even in the face of cosmic forces beyond our control, human ingenuity, methodical engineering, and a refusal to be rushed can prevail. It was a story not of brute force but of intelligent perseverance. The fire and thunder that lifted New Glenn from its pad was not an ending but a beginning. It was the opening line of a new chapter in our species' long and unfolding story of exploration, a chapter that promises to take us further than ever before, to worlds that have until now existed only in our dreams. The journey to Mars is long, and for the two lonely probes it has just commenced. But they travel not just with scientific instruments, but with the full measure of human hope, a hope that was forged in fire on a humid Florida night, finally unleashed upon the silent waiting sea of stars.